Up to now, we've been executing Python statements one by one. That is, we type in a statement, we hit enter, and Python executes it. But what we want to do now is look at a section on Python programming, also called imperative programming. So in this section, we're going to start by looking at creating a Python program. So what's a program? Program is simply a sequence of Python statements that are executed in series. Some of the things we're going to look at in this section is how do we control the flow of statements, and how do we reuse code. Often when we create a series of statements in Python, we might want to reuse it because we want to do that function again. So storing them in a program allows us to do that. So we're going to look at creating a Python program. We're going to bring up our idle environment, and we're going to look at some new options. Now you can't see my menu structure here, but at the top of idle there's a file menu, edit, shell, debug, and so on. In a Windows system, under the file menu, you may see something that says new window or new file. On a Mac here, I'm going to choose the new file option. And what that does, what you can see here, is it brings a new window that I can now start to create a Python program. Now, where are we going to store our programs? Well, in your file structure, I recommend setting aside a folder just for Python programs. So in the Mac, it's called Documents that I'm going to use. In a Windows machine, it would be My Documents. So I'm going to create a new folder here called just My Python, for my Python programs. You can call it anything you want. Oops, come on. And inside here, I'm going to have a separate folder for each of the lab assignments. So this one is Lab 6. So now what I've done is I've set up a place where I can at least store that. Here's my Python window. So one of the first things we want to do is create our program. I'll move this over so we can see the lines of our Python program that we're going to create right here. So these are just Python statements. Line 1 equals hello Python. And the nice thing is about a program is it doesn't execute the statements until I'm all done. So what I've done is assign two variables. So I created two string variables. Now I'm going to use something, we haven't used this print function before. We'll talk more about that in a bit, but we're going to print line 1. We're going to print line 2. And that's going to be the end of our program. Now, to save this, there's a couple different ways it can happen. We can go up to File and just hit Save. The very first time it's going to look at where do we want to save this to. So under Documents, I've created My Python Lab 6. We're going to call this Test. All Python programs have to have a .py extension. We're going to hit Save. Now, if you make a change to this, you'll want to save the change before it gets what's called executed. There's an option that on a Mac you get to through idle preferences. Idle preferences. It may be called options or preferences in the Windows environment. And when you bring that up, you can change things like your fonts, what they look like, the size of the fonts. I've selected 22-point font. One of the options here, by default, when you run a program, it will prompt you to save it. I like to choose no prompt so it automatically saves it every time I run a program. So we've typed in our program, and now what we want to do is we want to run it. And there are two ways to run a program. From the menu structure, you can hit Run and Run Module, or you can simply hit the F5 key, which I tend to use. So if I hit the F5 key, What happens is it runs every line in this program but shows the output on the shell. I'm going to add a new line here. And as soon as I run it, it will save that and again then just execute it on the shell. Now if my module here is not highlighted, if it doesn't have the focus, when I hit F5 I'll just get an error tone. So this needs to have the focus, F5. Notice what Python's doing here is it's also restarting the shell. So what does restart do? Restart wipes out any variables or assignments that you may have made. For instance, I can say line 1, which I've used in my program, equals new line. But when I execute my program, restarting the shell wipes out all those assignments and just does what's in the module here. You can also restart the shell manually. First, you must have the focus in the shell, and then one of my menu options is called shell. I select shell, restart shell, and that does a manual restart of the shell. So let's look at our program. This is a flowchart of our program. It's a graphical representation of what our program is doing. Flowcharts are one way to document the flow of a program. Typically it's written in English. You'll see some Python statements here. But this is a good documentation step before you start your program. Editors. You'll notice here a special Python editor. Why don't you use an editor like Word? Word is a graphical word processor, and Word has a lot of capabilities of bolding, changing fonts, and embedded into a Word document are all kinds of hidden special control sequences, sometimes called escape sequences. You don't want these extra characters in your Python files. You basically want a text editor, and so you shouldn't use any word processing editor such as Pages or Word or WordStar, WordPerfect, anything like this. IDLE is what's called an Integrated Development Environment, IDE, and there are many IDEs that you can use for Python. Some of the advantages of this is that it has a text editor and it uses coloring. So as you can see here, keywords like print that Python recognizes as functions are in one color. Strings are in a different color. This helps you debug your program. You can use IDLE, you can use Komodo, PyDev, which is part of Eclipse. There are many different types of IDEs that you can use for Python. So if we look at our module, we can see it is here stored in our directory. We can open it with any type of text editor. We'll just bring up a basic text editor and we can see that all the lines are here. They're not colored. Only if we open them in IDLE will we see them colored, but it's all here, and you could add to this using any text editor if you wish. So our basic module here is what's called a user-defined module. Math, fractions, turtle, those are all built-in modules. So if I look at my shell here and I go import math, what I'm doing really is running math.py, which is a file that's buried somewhere in the installation on your computer. And as I run that program, it has all kinds of built-in functions, such as square root, sine, cosine, and so on. So Python comes with a standard library which has all kinds of built-in modules which you can run by using the import command, but you can create your own user-defined module which you can run manually. One of the built-in functions we're going to look at now is called the print function. And the print function is designed to generate output on the console or the shell screen. If we type print with nothing in brackets, it actually skips a line. You can see we've got a blank line here. We can print numbers like that. We can print lists. And it may seem like this is nothing different than just putting the list. For instance, whoops. And you notice I haven't put the closing bracket, so I need the closing bracket before it'll print that. Really, that's not much different than doing this. It's a little bit different with strings. So if I put a string here, notice that it prints it without the single quote here. If I have a statement like this, I can use print to print the value of a variable. So print's often the way we use to generate output on a console screen. So we've looked at output. Let's look at input. To get input from a user, we use an input command. So for example, input, and I'm going to put a prompt here, enter X, which will give the user, and I'm going to put a space. And what happens here is that it prints the prompt, it waits for the user to type some input, and then it creates an object, and it actually creates a string object and then assigns it to the name X. So enter X, 34. Now if I want to print X, we can see that's 34. But if I do a type of X, we'll see it's not a number, it's an actual string. More on that in a bit. Let's give another example. I'll say F is assigned to, I want to get someone's first name. And whoops. Let's generate a program instead, because this is going to execute line by line. So let's create a module. Sometimes we save these right away. My Python Lab 6. We'll call this one just name. And what we want to do here is F equals input, first name, name. And now I'm going to generate some output. So I'm going to generate a new string, hello, and I'm going to concatenate what I've stored in, L. Now, you see I've typed a double quote there. We'll talk about double and single quotes in a bit, but I should have used a single quote because I started with a single quote. I'm going to concatenate that with the value that's in L plus F. So I want to print all that, and let's see what happens. So we'll look at our shell. This has the highlight, the focus, F5, my first name, Dave, second name. So I see an error here. Maybe I want to go first name and then last, plus I want a space in between. So what's nice about having a program is I don't need to retype all this. I can go back and edit my program. So let's change this to F. I want to add a space, so I'm going to concatenate just a space. I'm going to add the left name. Now every time I hit run, it's automatically saved. So my program is resaved. Dave Crab. Hello, Dave Crab. Now, as I mentioned, every time I enter something, it's treated as a string. We showed that above there, but sometimes that's not obvious. Input, sorry, x equals input enter num. And there are times when I want to add a number and have it treated as a number. So I've added x, and now if I do 3 times x, of course, I'm going to, because it's treated as a string, I'm just going to get the string repeated 3 times. So what are some of the things I can do to try to change that? Well, I could use an int function. I could, after, type x equals int x. And now, if I did 3 times x, x is now an integer, so it's treated properly. There are better ways to evaluate string expressions, and one is to use a function called eval. So eval takes a string as an argument and evaluates it as a Python expression, returns a number generally. So we'll take a look at how eval works. Eval 3, and it may not be obvious if that's a string, but if we type, let's do this, x equals eval 3, and then do a type on x, and we see it's returned an integer. Eval can do math as well. So here it will take the string 3 plus 4, it will convert, it will actually evaluate that string, meaning it will take the 3 out, add it to the 4, it'll actually do math, so we can return 7. And we can do things more complicated. In this string is going to be the length of a list that has 4 elements in it. So we're hoping that it will evaluate the string, say, I want the length of this, and return the number 4, which it does. So if I needed a number, we could do something like this. X equals eval. Here I can use eval to, along with the input statement, enter a number. Make sure I have a second bracket. And as that gets executed, enter a number, 34. And now if I look at the type that x is, I'll see it's an integer. And it doesn't matter if it were 3.44, it would return it as a float. So I'm going to use one of the features of my shell here to show that. If I just put the cursor anywhere in a line and type enter, I'll repeat it. So I'm going to enter a float, and now I'm going to look at the type of x, and we're going to see that returns a float. So eval will take a string and evaluate it as an integer or a float, whatever is appropriate. For your little exercise to finish off our section here, we're going to get you to write a little program that's going to request a temperature in Fahrenheit, and it's going to print the Celsius value using this formula. So your job is to create a Python module, a program, put statements so that it'll generate this type of output. As a user, you'll put this input 50 and see if you get this output. Pause the video and then we'll show you how to do that. Okay, let's look at our first attempt at our little program here. We first want to enter the temperature in F and put it in some variable. So we have an input statement, enter the temp in F, and whatever's put in we want to put into F. We then want to use a formula, so 5/9 times F minus 32. And notice I have to put brackets because the F minus 32 has to be done before the multiplication to 5/9. So 5/9 times F minus 32. Sometimes you have to just work at a Python shell, make sure you get this line right. You can do this by trial and error before you put it into your program. Finally, you're going to want to print some text. The temperature is, excuse me, and notice I put a comma here, and then I want the C variable. So I'm going to execute this and put in 50, and notice I get a mistake here. String and integers, I've got some type of type error in here. So use this as feedback. What's happening is, remember, the input statement is, even though you're typing in a number, putting it into a string, and it says take a string and subtract from it. Well, that's a mismatch. You can't do a math operation with a string. So we remember we used our eval, and eval takes our string that we get from the input, it converts it to a number, and now F is assigned a integer object or a number object. We can use a float or an integer, put in anything we want here. So now let's try it. So we could put in 50, but we could put in 50.1 if we want to. The temp in C is 10.05555. And we'll look at how we would maybe change this to display this, maybe just a 1 decimal point in a little later assignment. So that's your first look at creating Python programs and using a print, input, and eval function.